On this episode of The People of Manufacturing, we're going to start with man versus robot. We'll learn about manual machining versus CNC machining. Then we're going to check in at St. Petersburg College. We'll learn all about the Florida Apprenticeship Grant and the role of the community college with apprenticeship programs. And then we're going to check back with Bill Miller, the Quality Assurance Manager at Electro Mechanical Solutions, to show you what our apprenticeship looks like in real time. So let's start the show.
Are you ready to go man versus robot? Because you're about to on The People of Manufacturing. Let's go.
I love walking through any shop in America. It's got the smell of coolant, the smell of the safety. Got my glasses on. It's like default, and I know when I'm walking into a plant, I just need to throw these things on.
What's up, Uncle Gordy? I'm glad I get to have this conversation with you. Our goal is to share the difference between manual machining and what it means to be a tradesman versus a CNC machine and what the tradesman of the future looks like. And the value of your experience, because just going through that project with you and giving you the creative freedom on a lot of different aspects to where you can change things and all the engineering aspect of it, you know more about how to make things than just about every engineer I have met.
Right, hands-on experience.
That's it. So can you explain a little bit on how this, I know this is a knee mill, this is a manual mill, but can you explain a little bit on how this works?
Basically, you have three axes. You have X, which will move the machine this way. Y moves the table in and out, and your Z-axis is your quill. So basically on a mill like this you have three axes, and you make them work together to create the part. Most of the time you put the part you're working on, you can either hold it in a vise, bolt it to the table, or come up with a creative way to hang on to the part to use the machine. Make it do what you want it to do.
So whenever we're working with a student, a high school student, or whenever we do outreach with people and we're telling them the industry, we explain that this is where they should start. Because understanding this and where the industry came from, it makes it so much easier for them to learn a computerized machine.
Right. And with a manual machine, it teaches you how to think and how to plan ahead. You have to know, you have to think, okay, I have to start with this block of metal. So then you have to, in your head, you got to figure out all the steps that you have to go through to come up with a finished product. You have to know if you have to mill it first or drill holes first. And like I said, it teaches you to think. And like I said, plan out how you're going to do the whole job before you even touch the material.
How many years have you been doing this?
45 years.
45 years. So,
and I still learn something new every day. Every day I'll come up with another trick or something I haven't thought about. Doing a different way to do something that in 45 years it didn't dawn on me.
Yeah.
And then all of a sudden, boom.
Well, and that's the value of why we want to do this, is because that's 45 years of hard-earned knowledge that you're not going to learn anywhere else. So the biggest thing that I want to ask you is, early on, did you have a mentor? Or can you remember that key person?
Yeah, I had a lot of older people that I worked with that were always willing to teach and show me this trick or that trick or how they did it. And that's how I learned.
And that the value that comes with that is priceless. And so, and this is also a big part of what we talk about when we talk to people in the trade. If you're going to be mentored by someone that has 45 years of hard-earned knowledge, how do you determine if someone's worth teaching?
If they're attentive and they just act like they really want to learn, you can tell pretty fast. If you show somebody some stuff and they retain it and they're happy that they learned it, and you can tell that they're happy they learned it. That's how you tell them. When I was in my 20s, I worked with a guy named Chuck Gilmore. And he was a tool maker, he was a grinder. This guy was 83 years old, and he still worked because he loved his job. He loves to make parts. Well, I said, I can line this up faster and do this faster by hand than you. If you had everything programmed all this on a CNC machine, set it all up, install the tools off, I can do it faster over here because it's only one. It's one of.
And that's a awesome point, because like you said, this would probably take a whole shift just to set it up to even do what you're doing.
Right, and I can do the whole job in 20 minutes.
So if it's a man versus robot, the manual machine, the robot that powers it is the brain of a human. Gordy's brain knows how to make this thing work, and doing what he's doing right now is going to take at least a whole 10-hour shift to do, when he could just chuck it up and do it, because he can articulate his fingers with his brain, whereas inside of the CNC machine you have to tell it where to put it, and you have to program it in a second operation. So it's not profitable or makes sense to actually do this operation inside of a CNC machine. Uncle Gordy, it's been awesome talking with you as always, man, and I'm one of your biggest fans, so
stop by and say hello when you get a chance.
Done.
Now that we've seen what Gordy and the manual machines can do, let's go check out what the robot can do on the CNC machines with Bo Morgan.
A big objective of ours is to show man versus robot. Okay. So when we hang out with Gordy and Matt back there, it's manual machining.
Yeah. Yeah. Right on. I dig it.
So in manual machining, it has its place in American manufacturing. And we're here to determine if man wins versus robot.
Okay.
So we have a robotic CNC machine, and then you're making a part, and it starts out of a chunk of round, and this looks like aluminum?
Aluminum, yeah, 6061.
And so this looks like that you have a finished part.
Correct.
So can you explain a little bit on how this part was made?
Okay. A roughing tool, a finishing tool, a tree pan tool, and a groove tool. So this part was manufactured with 4 tools.
And about how long did it take to get that side done?
55 minutes per cycle.
55 minutes?
It's a mirrored image from op 1 to op 2, so it makes the setup really easy. The tools are touched off, the machine is ready to go. Concentricity is not an issue. We go from here to here, and the concentricity, the run out, is within 2,000 automatically. So man versus robot.
So with that being said, how long do you think it would take to make this in a manual lathe?
Double the time. Double the time, no coolant. I mean, there's so many CNC features that just trump the manual.
Yeah.
The tool approach, where we're mirroring the image, we can just flip it over and run it again. They would have to set up jaws, they would have to retouch off tools, they would have to watch their tools, where we can walk away and make money.
Gotcha, that's what it's about, right?
What it's about.
And how many of these guys do you have to make?
On this run, we have 3 POs for 1 order each, or 1 part each, so it's just a 3-run job.
So you're looking at total, you can smash these all out in half of a shift.
Oh yeah, 4 hours worth of work.
And then
we're on the manuals, you're talking a day and a half work. Plus the mess.
Yeah.
Plus the safety issues of your hair getting caught in the lathe, or there's no covers, there's no coolant. Yeah. It trumps it. It's hands down robot. That's the rock and roll button.
Got it.
So we basically just roughed off all the metal, and we're going to do a finish off now. Finish pass.
Awesome.
So the machine's ready for it.
Ready for rock and roll?
Rock and roll button. Here we go. Go to home position. So we take 2,000 per on the boss, the journals, and the overall dimensions. This tool is finishing everything in one pass. The concentricity is key.
So after the first tool ripped away the first set of metal, that's your roughing operation, right?
Yep.
And then, so this one's the finishing, so this is a little bit more of a fine touch, right?
Absolutely.
So
this is where the finish takes place, and the finishing dimensions are held.
So a new metal baby is about to be born.
Up to 0. No. That's the distance to go. So as that number gets smaller, you're going up. You're going to wrap these.
So this shows your position within the machine, right? So like on a manual machine, the X, Z, and B.
Yep.
Those are the moving parts and the different knobs that Matt would move back there, and that Gordy would move.
X and one Z.
Got it.
Here, when he breaks this part loose, he's going to get a different reading from this part to his next part. We're going to get the same reading within 10 thousandths of an inch.
Awesome.
Part's complete. That pass is complete. We're going to go to the next op. We'll check the part.
It's a great finish.
Yeah, very nice finish. Very consistent. We're shooting for 995. We're 9946. Exactly what we planned. Nailed it. Well within tolerance.
So because of the precision and the depth that they have to go, I mean 4 decimal points, you have to be perfect. So here at Electro Mechanical Solutions, they also have a quality assurance department that he works hand in hand with, where they have what's called a coordinate measurement machine, the CMM. That's a big part of this business, so they can actually go after this type of precision work.
Robot wins every time.
Why does robot win every time?
You want to make 1 or you want to make 100?
Valid point.
Robots are the future.
Greg Serio here with the people of manufacturing at St. Petersburg College, Clearwater campus. We're here to talk to Susan Biszewski-Eber and Gabriel Yeager. Come inside and let's find out more.
How are you today?
I'm very good, thanks, and glad to be here.
Likewise. We've been working together for October will be 2 years.
Yep.
Over the course of the 2 years, you've really helped me find the way for my company to actually register our standard. So we worked with Susan directly over about a 2-year period to build a standard from scratch. So because of the complexities of apprenticeships that we had, Susan helped us jump over a lot of the hurdles that we didn't understand.
You've created a niche, and I think that's why all eyes are kind of on you. They're going, whoa, wait a second, this is a different take on what we've been doing forever and ever. My dad was a tool and guy. He had to do his 8,000 hours. My brother's a welder. He had to do a type of apprenticeship. But what you're bringing to the table is so appealing that not only the person coming into the apprenticeship program, but also the companies are going, wow, if we could upskill someone in that quick of time and literally develop them to fit our culture. So it's taking that curriculum and saying, what kind of machine do you use? Here, I can come out and I can help you work that machine. We can't do that in education. We can't do that quick. We can give you theory, we can give you a machine to work on, but in terms of that flexibility of that related technical instruction, you got it.
Part of St. Petersburg College, it's a huge organization, and it took a while to understand. Can you explain how you ended up in this role and why you accepted this role?
Any educational organization is very large and it's a little tricky to navigate. Networking, communicating with my peers, my colleagues, that kind of helped me understand there's so much more to education than just your simple 2-year degree or 4-year degree. Through that, I found out about the apprenticeship program, and I went and spoke to my boss, Susan Biszewski-Eber, and learned about the apprenticeship model, and I found, hey, that's a solution for the talent pipeline that I want to be involved with.
Robotic integration, that's something that we're passionate about, and we have our other segments, man versus robot. In your experience, what kind of apprenticeships work best with emerging technologies?
So I think that the machinist piece that you came up with is a very interesting piece, and I think there's even room to throw on a robotic, so to create another apprenticeship that would be specifically a robotics apprenticeship, and I think there's real room for that. I haven't heard of any so far in the state of Florida, so I think we can be real cutting edge there. That's number one. Number two, and you brought this to my attention, is I didn't realize how important robotics were, but I also didn't realize what the draw was for young people in robotics.
The manufacturing industry as a whole is totally evolving right now with the integration of robotics. in artificial intelligence, i.e. machine learning. How do you see the future in workforce development with this emerging technology?
That's a great question. In my opinion, looking at everything that I have seen in advanced manufacturing and robotics, it seems to me that where we're going is more of a technology focus, and that technology-based training is something that education and learning institutions can provide, and it's going to require that changing workforce mindset for people to acknowledge that and actually go ahead and say, the industry is changing as a whole, so let me go ahead and change with it as opposed to fight it, and just embrace that change and go ahead and learn those new skills and train your employees those skills that they need.
It's developing a pathway towards economic mobility. I think for so long, people decided to go into higher education without really understanding what was out there. I know myself, as a first-generation college student in my family, and I didn't know what I would even go to school for. So I think that advanced manufacturing and this apprenticeship in particular can really open doors for a lot of our young people in high school, a lot of incumbent workers, our veterans coming back who are looking to connect up with. They've had all this magnificent training through, really, our armed forces really trains people to do things well.
Highly trained individuals.
Exactly, and then they come back here and it's like, okay, where can we put you? Right now, there are 6.2 million unfilled jobs out there for skilled workers. 6 million. We have our unemployment rate is only 3%. So we've got to bridge that gap. This gap that we have right now in unskilled workers is probably the largest gap we've ever seen in all of our history. You help people become successful, you build their confidence. I can't think of anything better to do. You've now made somebody feel like they're a contributing part of our society. You can look at that with CARD. You can look at that with Pinellas Ex-Offender Reentry Coalition. You can look at that for Ready for Life, which is foster care, youth aging out of foster care. So there's that human capital, there's potential for human capital to really shine. Again, going back to apprenticeships, and what you came to the table with was so unique of an idea that said, let's cut the time out rather than it being a 8,000-hour apprenticeship. Let's see if we can't do this competency-based, get people out there working quicker, get them into the community, help them to feel like a valued member of the community, and I think that's where it's all just come together for us.
One of the talking points that I wanted to talk to you about, because I know you work directly with a lot of employers in the area, is what role do you see the community college playing for bridging skill gap? And by skill gap, I mean just not any specific industry sector, but the ones that are hurting.
Okay. Yeah, so the community college, really the model of the community college is we're there. It's in our name. We're here to help the community grow. And that's not just for any one industry. That's not just for the individual, but that's also for the employers that we are connected with and with the individuals that we want to see grow. So not speaking of any particular industry, but manufacturing comes to mind, we see that there's a need in the area with our massive growth in the engineering community that we want to help fulfill those needs for positions, and the apprenticeship model is one of the ways that we've found to be successful in doing that.
From my understanding of economic impact, for every job that's created in the industry, whether it's IT or these high-paying, high-skilled jobs, how have you seen that bleed out into the community and how it affects the surrounding community of these employers?
So the whole idea here is as we draw these companies into the Pinellas County and Tampa Bay area, it's going to benefit not only individuals and give them more options and choices, but it's also going to benefit the infrastructure of the county. So think bigger picture. We've got to, every urban city has to start looking at what their aging infrastructure is. How do we build better roads? How do we create green spaces? How do we, keep things beautiful, if you will? And so bringing all of that, so it's sort of like the ripple effect, right? People begin to feel good about themselves, they feel good about where they live. This brings shop owners and really starts to create, as you had mentioned early on, an ecosystem that really benefits the whole Tampa Bay area. So it's a win-win for everybody. I am so proud of you, and I'm so proud of the work that you've done, and just as I watch the videos come out and I watch other people appreciate you, I know this is it. This is it.
Do it. Cry.
No, I won't.
If you want to learn more about SBC apprenticeships or just apprenticeships in general, you can follow our website by going to stpe.co/SPC apprenticeship.
Thank you, Susan and Gabriel, for the opportunity to talk to you about the Florida Apprenticeship Grant. If you have a community spotlight that you would like highlighted, please contact us at info@tpomfg.com. Now we're going to check in with Vishal Vellody and Bill Miller for a team spotlight of what our apprenticeship looks like in real time at Electro Mechanical Solutions.
Hi guys, Vishal Vellody here today with the people of manufacturing here at EMS, and I'm going to give you a grand tour of the whole machine shop, and after that we're going to talk to Bill Miller and see why you would want a CMM in your machine shop and how it works. Let's go! No place I'd rather be than beautiful sunny Odessa, Florida. If you guys already watched the electric longboard video, you guys will know what the Cincinnati brake press is. And what we used this machine for was a rider needed a cover to keep all his electronics on his longboard. So we came here and then we made flanges on the aluminum plating that we used for the cover. And then over there is the laser where we cut his parts. And let's go check that out. This is the machine that we use to cut rider's cover for his electronic longboard. Right here, these are actually 3 huge suction cups that take these big sheets of aluminum and they put it on the beds right there. So with this laser, it actually comes with 2 separate beds. While your other piece is running and cutting, you can get this ready, and then once your piece is done, this will lift up and then the beds will switch. The laser, how it works is it's ignited by 3 different gases: nitrogen, oxygen, and carbon dioxide. And then there's little mirrors inside there that reflect the lasers and concentrate it enough to where it can get small enough to cut all the metal. So then here on the actual metal, you can see everything's cut, and then all the shavings come down here. And then this is high-grade steel. The laser isn't strong enough to cut this, but it is for the aluminum. Sometimes the laser does get too hot and it does nick these and we have to change them out. But what's cool is that if we set the laser hot enough at the right temperature, then we can cut more of these. So then we cut parts to fix the laser with the laser. Here's a brochure for our new machine that we have here. This is the Doosan Puma 1800 series. This is going to boost up production in our machine shop, and it's going to change everything just by having this one machine. Oh, by the way, I'm a fan of Puma shoes here. I love them, I wear them all the time. The only problem is I don't have the steel-toed ones. I wish I could wear them in the workshop all the time. This is the Battle 4th axis mill that we have here at EMS. We do a lot of operations on here that require lathe and mill work. And if you guys are interested in seeing the actual tools that we put in this machine, we got a bunch right over here. So right here we have all our drill bits that we use, and then we have end mills on here. These are the bottoms of the tools that we put in the machine. The machine, how it takes the tools, it takes them out, puts them back in, is it uses a pneumatic pump on there. So it sucks this in, and then there's a little collet that holds on right there, and then the pneumatics lets go of the collet and pushes the tool out when you want to switch tools out. And then I have a lot more down here. I have saws, I have more end mills, I have a reamer right here. So right here you have your saw end mill, and then you have an edge brake right here. And also we have our reamer right here to open up holes. You know, if there's burrs inside the holes, we use that right there. And then here's all the different size collets for all the different drill bits we want to use for all of our different tools. We have all the different size collets here, and here is the actual piece. So you take your tool and then you put it right in there, and then you tighten this up, and then if you want to take the tool out, you just loosen this up right here. It's a little tight, I can't get it out. But this turns around 180 degrees, and then it's easier to take a wrench to this and change out your tool if you want. And then here's all the different wrenches that we use for that. They have specialized wrenches just for these that go right there. And then we also use an adjustable wrench. These are the only tools you need to actually come in here and then change out your tools. And then you take your drill bits or whatever tool you're using, the end mill, you put the right size collet in it. What I like to do is I like to put the tool in here first to check that it's the right collet size, then put it inside of the actual tool holder. So let's loosen this up, take this out, put it back. Now that I gave you guys a tour of the shop, let's go inside the inspection office and talk with Bill Miller, the quality assurance engineer.
Hey buddy, what's up?
How you doing today, Bill Miller?
I got to do a first article measurement on a little ring that they're doing out there on the CNC lathe. It's got a pretty tight tolerance on it. We can take a look at it. Just do a quick circle measurement here. And of course, again, I'm not using the DNC programming feature on this right now because I only have one part to look at, so I don't really want to start and do a full program. And because programming this takes quite a bit of time because you're going to go through everything you're going to do. This is the first piece, and once he gets done and he does everything else that he has to do on the part, I'll get the whole part and I'll have it sitting here in front of me, and it'll tell me exactly, you know, after I go in there what he needs done on and all the dimensions off the drawing, and take care of business. I'm not pushing the button. You notice I push that button every time I want to bump it up to get the reading.
So when you push the button, it decreases your speed.
It makes it so you won't crash the machine. Yeah, you can just kind of cruise in there nice and easy. Now go ahead and go into that wall, nice and easy. And as soon as you hear a beep, the machine told us you measured it. You can press the button, it'll go back to full speed, and then you want to hit the button again, and it'll go to measure.
All right. So once you make a measurement, does it take this control off and it goes back to full speed?
You can set it that way, either way in the software.
Okay.
All right. Now it detects a line, but it's detected the line from because you went like this to there to the center, and then you went back over, and you've only made 2 points. What it's telling you now is you just made a line from here to there. Now go ahead and do me a favor and hit it over there.
Alright, so when I make the 3 points,
it says circle automatically, it detects it.
Because you can't have a closed shape on the tube.
You got it.
Yeah.
And once you get the feel for the machine, you know, you'll start to remember, hey, if I press the button, see, there's your circle.
There we go.
And then if I wanted to stop it at 3, I'm going to pretty much bet you that it's going to be a little bit different number. Yep, look at that. We got, on this one, we had 6, 2, 9, 6, 6, 4. Okay, those last 2 numbers, that's 40 millionths you're seeing on the end. And look at this, on this one, it's going to be 6, 2, 9, 6, 7, 6. So you lost a tenth and 60 millionths there. On this type of a part with this size, we're going to be plus or minus 20 millionths on our measurement.
So when we have parts with really high tolerances, we actually do really need the CMM, and they sometimes require CMM report to make sure the parts are correct?
Correct, yes. We're as we move more into a lot of the aerospace parts and where there's tighter tolerances and you know, tighter the finish requirements are different, things like that. You know, with tighter tolerances, you're going to be taking. We also have a scanning feature where it'll actually drag that ruby around the whole thing, and that's the most accurate way to measure because theoretically when it's dragging it around that whole thing, it's taking up to 10,000 measurements. You know, I'm always glad to share any information I can with you, you know, you're doing a great job out there on the floor, and it seems like you just soak up everything I put at you. So, you know, we'll do more and more of this as time moves on.
Thank you for showing me how to use the
bet,
Mitutoyo coordinate measuring machine, and there's going to be a lot more to learn from you. Vishal Vellody here signing out. Thank you so much for watching this video today, and don't forget to share, like, and follow the People of Manufacturing, and there will be a lot more content to come. Ever see a machine take a big break?